Hello students, this is Amardeep Singh, your computer teacher, and today we are going to continue with the same chapter, handling errors and exceptions in Python. In this session we'll discuss about handling multiple exception types, adding an else clause using finally statement, raise an exception using raise statement in Python. So first we'll discuss about how to handle multiple exception types using except block. So as we discussed in previous session that try block is used to avoid the termination of program, and a try block always followed by an except statement that works as a exception handler, and the except block always execute in response to exception occurred in try block. We are having basically two types of except blocks. One is generic. A generic except block is a block that can handle all type of exceptions occurred in try block. And second one is specific except block. It's a block that can handle only specified exception occurred in a try block. So if you want to handle each type of exception separately, that means, for example, if you want to handle divide by zero exception separately, and type exception or name exception separately, then you can define specific except blocks by specifying the object of that exception class. Here we are having try block, then statements where exceptions are expected to occur, and if exception will occur in the try block, then control moves to except block. And in previous session we specified except block without any object. So if you will write except block without any object of exception class, then that except block is known as a generic except block, and that except block can handle all type of exceptions occurred in try block. But if you will pass object of exception class, or you can say the type of that exception with except keyword, then that block is known as a specific except block, and that except block will be able to handle only the type of exception uh, that you specify here after the except keyword. So, and if you will if you will define specific except block, then you will be able to define multiple except block with a single try. That means a generic catch block, you can define only one with a try, but if you will define specific except block, then you will be able to define multiple except blocks to handle multiple different types of exceptions with a try. So let's demonstrate how to use multiple except blocks to handle multiple exception types with a single try. So here we are having an example. We discussed this example in previous session also. So we are having code to divide two numbers, and we are going to handle the exception by using generic except block. Here we are having generic except block, and this except block uh, is having the ability to handle all type of exceptions occur in this try block. But it's not possible, or you can say it's not good to take the same action in response to each and every exception. For example, uh, let's try to run, and I will specify 12 and 2, the answer is correct. And if you will specify 2 and 0, then messages exception occurred here in the second last line. And but I want to display the message according to the occurred error, so I'll specify cannot divide by 0. So I have specified a message according to the occurred exception. So when you will run this code, and 12 and 0, the messages cannot divide by 0. So that means system is handling this error and showing you the message according to that particular error. So but if you will run the same code again, and now I am going to give 12 and second number as by. So instead of specifying a number, I am here specifying uh, incorrect type. So but the message is again same, cannot divide by 0. So is the problem, this one is the problem to use a generic except block, because generic except block can is having the ability to handle all type of exceptions occurred in try block. So it's not good to take the same action in response to some kind of exception, right? So if you want to handle the exception according to the type of exception, then you have to specify specific except block. So here you have to specify the name of that class. After that exception except keyword, you have to specify the type of that exception. So if you want to know the type of that exception, then you have to remove try block. Then we are having a mechanism to check the type of that exception. Just remove try and except block and run the program. We are using indentation, so we have to remove because no block is there. So so if you want to, because we can't cram all type of exception, because we are having hundreds of exception classes available in Python, so you can't cram all the exception name of exception classes. So just raise that exception, just I'll divide 2 by 0. Then exception class, name of exception class is here zero division exception. You can just copy the name of that exception here, and now you have to define try. Now indent this block. Now I'm going to uh, define except divide by 0 error, that is the type of that exception, and here you can specify the message that you want to print. Cannot divide by 0. So now this one is a specific exception block. So when you will run this code, then that block will execute, it will be executed when you will specify 0 as a second number. So now the error is being handled. Next we will again try to run the same code and specify any string instead of specifying any number. Then now again, so that means this one when you will use a specific except block, then that block will be able to handle only the specified this type of exception occurred in try block. But now if some another type of exception will occur in try block, then the program will be crashed, because we didn't specify any uh, specific except block to handle that kind of error, to handle this type of error. So if you want to specify this type of error, then after this except block, second except block you can specify here. After the closing of first except block, you can specify except the name of that class, the type of that exception, and print the suitable message according to the error. Please enter only numbers. So here we are having two except blocks. first accept block will handle divide by zero exception, and second accept block will be able to handle the value error that which will be occurred when you will specify wrong data type. And now try to run that one. In case of correct input, you will get the correct result, but in case of wrong input, I'll specify 10 divide by 0, then first except block is executing here, and when you will try to specify a wrong data type 12 by hello, then please enter only numbers. So that means if you want to handle each error separately by using a separate except block, then you will be able to handle uh, then you have to define specific except block by specifying the name of that particular exception. So we can define multiple specific except blocks, but if you want to define generic except block without specifying the type of exception here, then you will be able to define only one except block. Next, we will discuss about adding an else clause with a try. We can define else clause after last except. Else will execute only if no error occurred in try block. So that means, as we know that if exception occurred in try block, then that particular some specified except block will be executed. But if no exception will be occurred in try block, then after the successful execution of try block, the control moves to else block, and we can define else block with the try at the after the last except block if you are using multiple except blocks. So that means you will be able to define else block after the except block. So let's demonstrate how to use else block. So we are just continuing with the same example. So here we are having try block and two except blocks, and after the last except block, I'll define else and print any message or anything that you want to write here. So I'll specify else block executed. So I'll specify this message only. So now I'm going to specify uh, correct input, then that means the program will be executed successfully. And now you can see after the successful execution of try block, then else block execute, and after that the last line of the program will execute. And if you will specify, if some kind of exception occurred in try block, like I'll specify 12 after that second number as 0, then else block is not execute is not going to execute here. So that means with the try block you can use except as well as an else block, but only except or else block will be executed at a time, like this. So if exception occurred in try block, then else after the exception occur in try block, then that specific except block will be executed. And if there is not any error available in uh, occurred in try block during the execution of the program, then after the successful execution of try block, then else block will be executed. Next, we will discuss about a finally block. A finally block will always execute even if error occurred in try block or not. So that means finally block basically is used for the purpose of performing finalization task. Finalization task in any kind of software are used to perform some uh, activities like closing the connections, closing database connection, closing network connection, or such things. or you can say performing some kind of a garbage collection task. So that means if you want to write any kind of statement that will execute even if error occurred in try block or not, then you have to write that statement inside finally block. And finally statement, finally block must be the last block in, with the try block. So that means if you people are having multiple except blocks with try, then you have to define finally after the last except block. And even if you are using except and else block also with the try, then after the else block you have to specify finally block. So the purpose of finally block is to perform finalization task. And again I'm going to repeat, a finally block will always execute even if the exception occurred or not in try block. So that means if exception occurred in try block, then after the except block, finally block will be executed. And if no exception occurred in try block, then after the completion of try block, then the finally block will be executed. So let's demonstrate how to use finally block. Again, I'm going to continue with the previous example. So in this example, we are having two except blocks and one else block also with the try block, with the try statement. So if you want to use a finally statement, then you have to write after the else statement, but use of else is not required. If you don't want to use else statement, then you can also use the finally statement without any else statement. So I'll just print a simple message, this is finally block. So when you will now, if exception occurred in try block, let's suppose divide by 0 exception occurred in try block, then the control moves to 0 division exception. Then this message will be printed, and after execution of this line, control moves to finally block and it will execute this statement. And if no exception occurred in try block, then according to this example, after the completion of this try block, the control moves to else block, and after the completion of else block, again finally block will be executed. So finally block always execute even if error occur or not in try block. Let's try this one. So I'm going to specify correct input, two values, two numbers, and the result is here, result is 4. Then after the completion of try block, else block executes. Then after that, after the else block, finally block executes. And again, if you will try to run the this code with some kind of exception, then let's try. Now the exception will occur in that code, and division by 0 exception occurred in that code, and after the that except block, the finally block again executes. Now so that means the finally block always execute. It doesn't matter if the exception occurred in that particular try or not. So that is the use of finally block. Next, we'll discuss about array statement in Python. Array statement in Python is used to generate or throw a user-defined error in a program. By using this statement, we can customize the error message generated by a system when some kind of exception occurred in a program. But so with the help of this statement, you can define your own error message belong to some specific type of exception. So by using this array statement, we can generate a user-defined error message. So let's demonstrate how to use array statement in a program. As we discussed in the slide, that array statement is used to generate a user-defined error message, and with the help of this statement, we can explicitly generate an error in a program. So first of all, I will simply generate an error. raise. This statement must be followed by the type of exception that you want to generate. For example, zero division error. You have to type the name of that class, and after that inside the bracket you have to specify the user defined message. If you will not specify the user defined message, then it will generate, raise statement will generate this type of error without any reason, because in this program we are not having any statement for where we are dividing a number by another number, and the raise statement will generate an error in a program. So if you will use like this, then it will generate error message without any kind of user defined message. It will show you the system defined message. uh, there is no need to specify this colon symbol. Then press F5. Now you can see that an exception occurred without any reason, without any exceptional statement. Exception occur, and the system generated messages raise uh, zero division error, zero division error. So that means it generates that type of error. If you will specify the message that cannot uh, divide a number by 0, save it and press F5. Now you can see that the message has been generated by, that means division error, zero division error has been occurred, and the message, here we are having the message. So actually in the source code of Python internally they make use of raise statement to generate runtime errors.